Go.
0,
Yep.
1/2,
Yep.
1,
Yep.
1 1/2,
Mm-hmm.
2.
2. Excellent. Can someone tell me the second row? What's the second row going to be? What are you going to do to all those values? Yeah, so you get 0 squared, 1/2 squared, 1 squared, 3/2 squared, and oh, there we go. Okay. So I would like you to estimate using n equals 4 the area under that curve. You now have the table. Use n equals 4 to find the area under 7 over 4 plus 15 over 4 divided by 2. And what'd you end up with?
11.
What?
Isn't it 11 over?
11 over 4? Yeah. There you go. Right? Just do n equals 5. Do not yet do n equals 100. Do not do that yet, please. Don't even try yet. So when you fill this in, what do you have to do to each of those numbers? Cube them. So it's that cubed, 3/5 cubed, 6/5 cubed, and so forth, right? So then you do the exact same thing you did before, except the numbers are a little bit less cool. So what's the interval now? 3/5 times what? What's the first one? 0 cubed plus 3/5 cubed plus 6/5 cubed. And what are you sensing right now as you do this? What are you feeling as you do this? It's ugly, yes. So there's your, not 0, it's a lower bound. And then what's the other one going to be? It's very similar, except where do you start? 3/5 cubed plus 6/5 cubed. So it's ugly. Now when you do things like this, what is better suited than you to do things like this? So what do you have to use right now to do this? Use your calculator now and please estimate both. Please find the exact 29 point what?
16.
So if you wanted to get the estimate, what would you do with these two? You would add them together. Plus 29.16 divided by 2. And what do you get? 21.06. That is a great estimate right there. So you should have felt a little bit annoyed right now because that is annoying, but you have to be able to do it. N equals 5 with that type of fraction is about the most intensive calculator work I'll have you do on Riemann sums. Now, what happens if I said do it with n equals 100? What would your reaction be? That'd be stupid. Stupid. Okay, so I want you to go up to the top of this page and load this website right there. I gave you a nice website right there. Open that website up. It'll look like this. What function were we dealing with? What was it? What was that last one we had? X cubed. So what do we enter in right here? What do we enter in for our function? X cubed, exactly. And then we're going from what to what? What's our lower bound? X to the third. We gotta do x to the third. Nice. And what's our lower bound? 0 to what? 0 to 3. Let's just check our answers first. We did with what, 5 estimates right there? And we did the left. Let's replot it. Oh, look what it does. Look what it gave me right there. Look over to the left, everybody. Take a look at that. Is that exactly what we got? 12.96?
Yeah.
Oh, and then you did the right one. Hit replot, and oh, 29.16. Is that exactly what you got? Yeah, it is. And then the actual value, it tells you the perfect value, which is 20.25, which is pretty cool. Which one's different than what you got? Yeah, because it's still an estimate. The average is never going to be exact because these are curves, not lines. Mikey, Annie, Caleb, how are you feeling about this? Does it make sense what I just did up on the computer? Yeah. Okay. We're getting there. That's what we're getting to, okay? So how do we make the estimate better? You have more what? The estimate gets better as you have more what? Rectangle. So we want to, instead of 5, do how many? 100. Let's do the left bound first and hit replot. Boom. It takes a second and voila. Look at what the estimate now is. Let's clip this in. This is with 100 right there. Take a look at that. Is that even closer to the actual? I know you're asking yourself, how does the computer do that? But we'll get there. Look at that. That's pretty cool. It's even closer, right? So that's with 100. Now if I go back, I could do the right hand and it should be above. Oh, it is. Is it slightly more above now? Oh, it is. Exactly. So that's the right hand right here. Here's the right hand. Oh, that's not what I wanted to do. Let's move this and put this one here. Exactly. So can you use this website to do a lot of your Riemann sums for you to verify? Absolutely. Absolutely. Now, if I wanted to make the estimate even better, we just need to increase the n value. What n value do you want to use to see if we can make the estimate even better? If we went to 100, why don't we choose what? Anybody want to guess what it looks like when I hit enter? What's it going to... Yeah, so what's it going to look like? Give it like 5 seconds. It takes a second, but 3, 2, 1, come on. Boom. Boom. Come on, you can do it. Boom. It's still calculating. Still calculating. Takes us. Oh, look at that. It's just black. And look what the estimate is. 20.29. Is that closer and closer and closer? So the more rectangles, the more accurate it gets. The height doesn't change, but the width does. Yes.
How would we get 20.25?
We're not there yet. That's like another 3 classes from now. That is another 3 classes from now. But the point is, we now have an applet which you will eventually load onto your calculator, which will do a very similar thing for you on your calculator. Very similar thing. 8, and if you simplify that, that's 1 over what? 1 over what? You can do it. If I made the top 10 times bigger, I have to make the bottom 10 times, 1 over 80. So we know delta t is 1 over 80. So the width of each rectangle needs to be 1 over 80. The width of each rectangle needs to be 1 over 80. So if we want to know the number of rectangles total, what is the n? Do you remember what n equals? The number of rectangles total.
Yeah.
You go from b to a, but what do you divide it by? Delta t. So what's b in this case?
3.
A is
1.
over 1 over 80, so that's going to be 2 over 2 over 1/80th, right? So what's that equal? 2 times 80 over 1, which is 160. You have the interval 1 to 3. You need to break it up into pieces that are 1/80th wide. So how many of them are there? There's 160 of them. So if you want the degree of accuracy to be within 0.1, you have to have at least 160 of them. If you wanted it to be better than 0.1, what's the minimum number you would need? If you want it to be better than 0.1, what's the minimum number you'd need? 161. You need it to be better. The estimate gets better as n gets bigger.
Sorry, I'm just a
Go
little
ahead.
confused with how you got that.
Minus f of a times delta t has to be equal to 0.01. So what's this going to be? 1/2 to the what power? 8 minus 1/2 to the delta t is equal to 0.01. So you solve for delta t, and what do you get? Like 0.041, I think. Is that right?
Yeah.
Is that right?
Yeah.
So if you want the n value, you know that n is equal to b minus a over delta t. What is b in this case? What's b? 8. So you have 8 minus 2 over 0.041. So what does n equal in this case? Who has it for me? What is it? 140 what?
6.341.
341. That sounds right. Exactly. What do I subtract? The integral of what? 2 to 4 of x plus 2 dx. You're subtracting one from the other. You're subtracting one from the other. My question to you is there any way to combine those two? This is just what you think you could theoretically do. How could I write that, do you think? Anybody want to guess?
If you just multiply the two.
We're not going to multiply anything. We're going to put them together somehow. Just guess. It's about as simple as it gets. The limits of integration are the same, so what can we do? You can just put them together because the limits of integration are the same. So you have x squared plus 4 minus x plus 2, like this. Oh, and then what can you make it? The integral from 2 to 4 of what? What does it simplify to? X squared plus, or minus what?
X
Plus 2 dx. Hey, excellent. And if I wanted you to do that with n equals 20, if you ever see n equals 20, are you going to do that by hand? No. What are you going to use? Use your calculator. Use your calculator. Not calculator, I mean use the applet right now. You're eventually going to use your calculator once I give you the program on your calculator, but right now you can use the better thing, which is the applet on your computer, which gives you a nice pretty picture and is faster. So do that for me right now. Let's use, do the left and come up with your estimate, and do the right and come up with your estimate, and then average the two.